So, hello everyone. Our today's session is on software testing fundamentals, which will be useful to everybody who is related to testing, product life cycle, softwares, even hardwares, because every product, whatever you make, unless you test it, okay, and validate it, you should not launch it in the market. Unnecessarily, it can have a lot of repercussions and your brand value can become less. So to start with, we have already covered a lot of topics, but we will like to cut it short and summarize it, and then we'll go ahead with the later topics. So we will be covering these in today's session. Importance of testing in SDLC, testing life cycle.
पिछले सांगायला लागेल ना.
So testing life cycle, test planning, types of testing, verification and validation, quality assurance and control, bug reporting. Let's see how much we can cover, and then the remaining we can take it in the next lecture. So introduction to software testing. As we all know that software testing is a process used to identify the correctness, completeness, and quality of developed computer software. So last time we discussed in our session that why do we include design in our SDLC lifecycle? So what is SDLC lifecycle? Software Development LifeCycle, where we have your requirement gathering, your analysis as the second phase. Third phase is your, what you call your, we have analysis, we have design, we have implementation and coding, we have deployment. If it's a long-term project, then we have maintenance. This is a part of software engineering. So I hope that this topic is clear. Otherwise, I can put the video in the description box regarding SDLC lifecycle for your recap. Or you can also find out through your net. So why do we include design in our SDLC lifecycle? It is basically to improve the quality. And if you are in IT related testing to improve quality and design, of course, then definitely you should add the object oriented concepts. So once you add the design fundamentals, that is your architectural patterns and design patterns, that's called high level structures. And in the low level structures, you have your UML diagrams. Then definitely this is your design. And if you add object-oriented concepts, then definitely you will have your quality enhancement to it. So if you're testing your product, you're basically finding out the correctness, completeness, and the quality of the developed software. Okay, so it is not only that, there is no bugs in the software, but also software testing is required to find out the quality of the developed software. As rightly said, if suppose there is a product which requires 10 seconds, which gives you 10 seconds of response, and another product gives you 10 minutes of response, and both are giving you the same outcome, then definitely the quality, one of the quality measures is the response output. Definitely the 10 seconds product would be having a better feedback. So it is the same that why software testing is required. So it is required to find out the correctness, completeness, and the quality. Okay. You have to know what type of performance it is giving, 10 seconds or 10 minutes as an example, how much reliable it is. Okay, so these all parameters are included in the test cases. Okay. So who should test? As we discussed in the last session, if it is a a system testing, integration testing, it is a unit testing or a white box testing. This all is done at the developer side. Whereas if it's a product testing or acceptance testing, as we had discussed the V test model, which was the first phase if you take it from the top and last phase if you take it from the bottom, then that is done by the client or the user. Even this we discussed in the last session with definitions, but I'll just repeat what is an error, what is a bug, what is a fault, or what is a failure, and of course, what is a defect. So a person makes an error that creates a fault in software that can cause a failure in the operation. So an error is a human action that produces the incorrect result that results in the fault. The presence of an error at the time of execution. So this is the software bugs, errors, or you can say the syntactical errors. State of the software caused by the error. Okay. They are also called as defects, which we discussed in the last lecture. So faults basically यार, it is यहाँ पे fault दिया हुआ है और हमने जो पिछली बार डिस्कस किया था उसको हमने defect कहा था. And failure is what? Failure is basically this is a cause of the defect which were identified. So deviation from the software. So last time we had discussed about the exception handling. तो अगर आप एक्सेप्शन सारे हैंडल नहीं करोगे तो आपका प्रोग्राम को आपको वो एग्जिट हो जाएगा एंड देन यू नीड टू फिक्स द बग एंड देन यू नीड टू रिकम्पाइल सो इट विल बी exited abruptly, whereas if you exception handle it, okay, it will not be exited abruptly. It will exit with a proper method in a closed loop with a proper message to the client. Okay, what went wrong? If the input was wrong by the client, it's not the developer's mistake, right? So who is the software tester? A software tester is the person, is the one, may not be a person, it can be also a system. So software tester is a one who performs testing and find bugs if they exist in the tested application. So as rightly said earlier that we have got SDQA certified software testers, they are highly paid. Okay, and they are dedicated to to create test cases. And what is a test case? For every functionality, we need to have a test case, which it starts from, the use case diagram and it closes to the use case diagram again. Okay, so पूरा आपका फ्लो जो हमने आर्किटेक्चरल पैटर्न में एमवीसी आर्किटेक्चर में आपका जो स्टार्ट होता है इनपुट वो एंड होता है, तो वो पूरी एक फंक्शनैलिटी है जो स्टार्ट टू एंड आपको उस टेस्ट केस में बतानी है कि इनपुट क्या होगा, कहां से स्टार्ट होगा, कौन से माइलस्टोन्स में वो इट विल क्रॉस. Okay, so in our technical terms, will it cross this class diagram, then sequence diagram, then deployment diagram, then database diagram? It all depends how you have made the flow of the project. And then finally, you have to close that test case. So if the test case is not properly defined, then you will not be able to identify the error of the entire system. And it may create a havoc or a wrong impression at the client side later during acceptance testing. So testing team, like we discussed, you have a project manager, which will actually be a mediator between the client and the project leader. So project manager's duty will be to communicate with the client, get all the details of the requirement gathering. Okay. And that is the part of the SDLC cycle, first part, requirement gathering. So in requirement gathering, mainly the project manager and the client will be involved. If suppose the project manager is not technically aware of the details, it can include or consult the project lead, project leader, okay, or here where we are discussing more about the testing life cycle rather than the SDLC life cycle, the project manager will consult to the QA lead, and it can always involve technical lead also. Then in the second phase of SDLC lifecycle, you have a SRS to be made. So in SRS, your QA lead, your technical lead, and your project manager, all three will sit, because project manager knows all the details on the client side, and it will be the technical leader or the QA leader who's going to pass on to his team, to the developer team. So both have to be involved to finalize the SRI document and get it validated and authenticated, if possible, with the client also. So that, SRS has a limitation. It has, it includes limitations of the projects, the input, output, clearly defined. Okay. And so if it is authenticated by the client, there will be no ambiguity later. And since it's also involved process models to be included, technical lead would be an added benefit to identify that clearly. So you have QA lead, you have got test analyst, which work under the QA lead. Okay. So if the project is small, the QA lead and the test analyst can be the same. Okay. But if it's a big team, then obviously any team has to have a controller or coordinator, and that becomes the QA lead. And you have the more like developers type ground level people, and that will be the test engineers. So if you want, I'll share you this PDF and the PPT link in the description box, and you can go to in detail about the roles and responsibilities of each. Okay, we've just discussed it as a whole, or maybe if not clear, we can discuss that as a separate topic. So importance of testing in SDLC. So as discussed, these are the phases of SDLC lifecycle, and maintenance comes on the long-term project. Like if you go and buy a cycle, you don't get a maintenance on it. But if you go and buy a car, you get a maintenance of say 3 months to 1 year, because it's a costlier product. So similarly, if it's a long-term project, its cost is also going to be more. So maintenance is generally a part of long-term project, but it depends. Even short-term projects might give, if it's in their affordability and domain. So these are the phases of SDLC life cycle. So the point is that why testing? Now we said that why design is important, because it enhances to the quality, and including object-oriented concepts like abstraction, inheritance, polymorphism, functionalities like overriding, overloading. We all know that these concepts, they promote modularity, and we all know what are the benefits of modularity. If your project is divided into clear modules, and if every module has a roles and responsibility and functionality defined, okay, like we saw in MVC architecture. MVC, the M stands for model, database. So it's a database designer's task to handle the data. So roles and real responsibilities are clearly defined. So if there is any issue created to database, you can contact the experts, the lead of the database. So it becomes easier to fix your errors, faults, failures, defects, whatever we discussed. So again, I'll repeat, design is important, and adding object-oriented will definitely add to the quality. And testing will identify the completeness, the correctness, and of course, it will also be one of the measure to validate the quality of the project. So the subject is itself software quality, design quality management. So we are studying design, which is the input to the quality achieved. So we know the SDLC life cycle that we have discussed is in software engineering. The testing life cycle, you can go through the V model, process model, which we discussed in last time. I will share you the link also again, where we discussed that in every phase, the testing should be done. It should not be done after the implementation. If the testing is done after the implementation and there is a defect in the design, you need to go again. And that's a waste of time, not only for the client to the project, but also you have to pay extra for that rework. So it is better that testing has to be involved in every phase, and that is well defined in your V model. V stands for validation, which we have discussed earlier. So assuming that you attended that session and understood it, this testing life cycle would be easier for you to understand. So we have system study where you need to understand the requirements. You create a test plan. You design the test plan where all the test plan will be that how many test plans will be created, how many functionalities are there that you need to identify. So first you identify the requirements, then you identify the functionalities, and on every functionality, you're going to create a test case. You know that MVC architecture start from use case till the stop again. So, and then you're going to execute this use case. If you remember, there is one session on automation of testing as an engineering activity. In that, we had a diagram where we initiate, we identify the defect, we execute the defect, and we close the defect. Okay, so execution means one test case we need to identify which we should start first, second, and then we should identify the defects in it and report it to the respective team. For example, it's an MVC architecture and the defect has come from the UI, so it will go to the UI team. How simple it becomes, if it is in a modular way. Then it will have a regression test. What is regression test? Internally, this developers type test engineers will see one page. If it's a UI, then they will try to start from the scratch, from the first page, and try to identify which page actually that defect is being created and the flow of it. So that is called as regression. Okay. And then we analyze it in the entire system, its relevance, and we create that report and we put it. Why report writing is very, very important? Because if the same error, if it occurs in the later stage, we need to backtrack it. So this report will be useful because we have already completed the half stage. So if there is an additional error, we need not start it from the scratch. This regression is already done. So maybe these summary reports will be able to identify the earlier at a more earlier stage, also faster, and the execution also time decreases if you have the past reports. So that is why that is very, very important. So next subtopic is test planning. So you need to create the test plan. So as explained earlier in short, a test plan is a systematic approach of testing a system, that is a software. So entire system you need to approach for testing. So then only you can identify how your test plan would go. So obviously, if your first UI page which the client is interacting, that will be the first page. And the last page with it is interacting, that will be the last page. Now, how to understand which is the first page and which is the last page? This may be the SDLC developers, project managers, project leaders may know. Not project manager, but project leader and developers may know, but the testers may not know. So they need to identify the entire test plan, the workflow of the system. Then on every functionality, a test case would be created. Okay, so if a website has a 10 e-commerce website, if you're creating and it has got 10 functionalities, so your 10 test cases would be created. If one functionality has 4 individual sub functionalities and every functionality has 4 individual sub functionalities, then you will have 4 into 10, 40 test cases likewise. So a test case is a specific procedure, okay, of testing a particular document. It is so well defined and it includes identification of the specific requirement test. So of course, if you want to test on an image, so your requirement would be image, and from where you will get it, that also you have to specify here. Okay. Then if that test case is a success or a failure, success means no defect. If it's a failure, that means you have defects. Then you need to identify the steps to be created to execute and find out the flow from where the defect has come out. And finally, you need to test the data. That means execute it. So next thing you need to understand is unit testing. So if you go back to our previous lecture on V model testing, where unit testing was a part of the requirement, not requirement thing. Requirement gathering was, business requirement gathering was, the arrow was to the acceptance testing. Just give me a minute. I'll show you that V-test model again. Yes, so you can see this V-test model where this is the developer's life cycle and this is the so this is the developer's life cycle and this is a tester's life cycle. So this is the verification phase. This is the validation phase. It starts from here. We get the business requirement. As I said that you will get it from the project manager and the client. Okay. Once it is finalized, then you have acceptance testing from the client side. Okay. Now the client side or maybe the tester side, both can be involved. Then you have SRS prepared by project manager and project leader. And you have system integration testing. So the point to be highlighted, then we have high level design where you have architectural patterns and design patterns. And that's a component testing. So that's what we said, model. So if you have any defect related to database, it is considered as a component. It will be contacted to the database designer. If you have any defect in the view, MVC, okay, V stands for view. So the component is UI. So UI testers would be involved in this. If you have a defect in the business logic, okay, so business logic testers will be involved in this. So architectural design is your high level design and the low level would be the coders, the developers and your UML diagrams. Basically, it is more of a coding. So unit testing means by line, you need to code. So not only line by line, but also as a module as a whole. Okay. So suppose in your component testing, you have business logic. In business logic, you will have class diagrams. So you can have 10 class diagrams encapsulated into a package. So every class diagram need to be tested and that will come under unit testing. So coming back to this unit testing, test each module individually. Follows a white box testing. White box testing, what is the difference between unit box and white box? White box testing is a logic in the program. So line by line code and identifying the errors and solving it. Whereas unit testing is the entire module. Okay. So it's done by the developer. I hope this concept is clear. Difference between white box testing and unit testing. I'll repeat, white box testing is done by the developer's side, code by line by line. It is for the logic of the program. So suppose you have written a main program. So the white box testing will include that the program runs properly. That means there are no errors. So it compiles successfully. But after compiling and running the program, you get the output what is expected. For example, if it's adding two numbers. Okay. So if suppose you get an error in the syntax, so that also will be solved by developers in the white box testing. But suppose your program compiles successfully and in the output, you do not get the desired output. For example, if I input two numbers, 5 and 7, so it is giving me 10, which is a wrong answer. So that means there is a problem in the logic. So this type of testing is called white box testing. Whereas module is, it's not one single program, but it's the entire module. The entire, what you can say, like MVC. M is one module, V is another module. Okay, like that. Similarly, if suppose you have a e-commerce website and you have payment details. So in payment details, you will have say 10 programs. So each program will come under white box testing, but the entire, all 10 programs consolidated into unit one unit as payment, that would be tested as a whole. So that is called unit testing. I hope this is clear to you. So now going to the integration testing. So once, suppose in your project you have 10 units. So now you need to integrate all those 10 units, and then that is called as integration testing. So, sometimes if suppose one module is in Java and another module is in Oracle. Now, Java doesn't understand Oracle, Oracle doesn't understand Java. So you need to have a JDBC, ODBC driver, that is Java, JDBC, JD, Java database, okay, database driver. ODBC means Oracle database driver. So you need to have drivers in between. So these all things in between, like deployment diagram, component diagram, you have to make those UML diagrams so that you understand that what type of drivers or components externally you need so that they all integrate well with each other. For example, one knows English and one knows French. So you need a translator, right? Unless and until you will not be able to communicate. And there is no use for those people to communicate also if they can't. So it is that type. So after completing the unit and integration testing through white box